Hi everyone, Engineer Liu here. Welcome to another video. Now, in this video, I'm going to do something a little bit different. I'm going to attack my own network to flood my own network to DDoS my own network with the type of attack called UDP attack. UDP, which is a type of network protocol similar to TCP, but it uses less data, so it is more faster and simpler. And it stands for User Datagram Protocol. So among with the TCP EP, it's one of the most utilized protocols. So yes, for that, I'm going to close this. I'm going to my GitHub. To do this, what I did is I went to a node program I wrote in C, which does almost exactly the same thing, and then adapted to Go because why not? Because Go is cool. So let me find here UDP floods on my GitHub, and there it is. Let me open both at the same time. Just a disclaimer, don't ever do this in computer systems networks you are not authorized to, or else you will face legal actions. So remember, with great power comes great responsibility. That's correct. So keep that in mind. That's really serious. I'm doing it on my own computer, so it's mine. I authorize myself to do it, but don't do it on systems you're not authorized to. Okay? So with that out of the way, let's dive in. So this is a pretty straightforward. It's not like simple, but let me open. So increase the font size a little bit. So there's a bunch of headers because it's supposed to run on Linux. So there's all sorts of sockets and syscalls specifically to the Linux kernel in order to make this possible. So yeah, you have to, since you're running a raw socket of sorts, you have to create a pseudo header for the IP protocol. And if I'm not mistaken, the only header that the kernel adds to the packet is the Ethernet header. So let's see here. There's, of course, I use it multi-threading with pthreads for that. And let's see, we have a check socket function, checksum, csum, that's what it stands for, handle signal for when I want to stop the flooding, you just press Ctrl C. Here's just some utility function, random int, because I was generated with spoofed IPs. For those who don't know what a spoofed IP is, it's a modified IP address, so you can hide the original IP address which sends the packet, so you don't get caught, so to speak. And here's the UDP flood, so to speak. So let's go to UDP flood. So it's a void pointer function here, and because it was supposed to pass its arguments to a pthread start, and then it starts as a thread. So there's a mutex lock here. So basically, it generates a random port number for where it will be directed. So AF INET, and then the get support, the target IP address. So here it has to do some conversion from string and so on. And then it sets a bunch of stuff here for the proto UDP packet. Let's see what it has. What else got here? The IP checksum. So here I believe, yeah, it's setting up the IP header, the Internet Protocol header, and then finalize with checksum, and then sets the UDP header, which is pretty simple. All we need in the UDP header is the source IP, the port number, and the size, and there's some flags probably here, and there's some checksums. Here's some memory allocation going on. This is very important. IP HDRINCL is how we tell the kernel that the headers are included in the packet. Otherwise, the kernel will include automatically the internet IP headers, and that will make the packet essentially invalid. So we cannot use it, and yeah, that's bad. So we need to use that this function set socked opt. Let me check. Where is it? So man set socked sock opt. It increases a little bit. So yeah, get socked opt and set socked opt manipulate options for socket refer to by the file descriptor socked file descriptor. FD, socket FD. Options make systems multiple protocol levels. These are always present at the uppermost socket level. Blah 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 blah. So I'm talking about this C function from the kernel because we will need to use in the Go code as well. So yeah. And then after that, we send the packet to wherever we want to. I got the port and the IP address, and yeah, voila. You spawn several bunch of threads, like hundreds, thousands, and then you got the denial service attack, and basically, yeah, we're screwing up the internet. That's what exactly I'm going to do, and I also am going to extract some metrics like ping, throughput, jittering, and so on, so we can see how bad my internet goes when I run my UDP flood. So that's pretty much it. Yeah, there's all the functions here. The function to basically create a spoofed IP address, so it's pretty simple. It generates 4 random ints, and then concatenates it in a string. And then, yeah, so let's go back to Go. So yeah, this is the repo you can access here. I'm gonna leave in the comments the source code so you can play around with it. On computers that are authorized, remember, don't fuck around. Remember the graph that chart. Fuck around, find out. Okay, so yeah, keep that in mind. You don't want to get into trouble because of this. So yeah, this is a repository that contains a Go application designed to create a send UDP package with a raw socket, intended for educational purposes only, to understand network protocols and raw socket program in Go. So any misuse of this software will not be the responsibility of the author or any affiliates. The end user is solely responsible for complying with all applicable laws and regulations in their jurisdiction. So guys, this is really serious. I'm repeating myself already, but because this is really serious, you can get yourself into legal trouble. So what we do, you need Go, and you have to run some of this as root, because in Linux the kernel requires that you create raw sockets with administrator privilege. And also we're going to using a Wireshark for analyzing these packets to see that we are actually getting spammed and it's working. And yeah, here's how to clone, blah, 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 usage. So basically what we need, actually this is out of date, but the only thing we need is a destination IP, and the port number will be random, and data payload will also be random. I'll show you later what I'm modifying the code. So here's a basic example. You can spam people with hello world or whatever message you want to send. Don't do that. So some features, it sets IP, ADA, HDRI, and CL. Socket option signal the kernel. The packet will include the IP header. Checksums for both IP and UDP packets are calculated to ensure the packet integrity. So it can contribute, feel free to open issues, and yeah, that's pretty much it. So now I'm going to open Wireshark to check. Oops. To check, I'm gonna pause the video because I don't want my password to be stolen. Done. So yeah, I think I can capture on wireless, so it must be, where is it? Oh, loopback. I think loopback will work. it must be LP2SO. So yeah, this is the one I'm gonna use. And on VS Code, let me see. Perhaps this should increase the font a little bit. Come on. Yeah, I think that's better. So this is only has one file. Admit this is too big. Okay, I think it's better. So here we have max ports, and that we use to generate a random port number. Oops. Max data length because when summed with the UDP headers and this size of bytes, you don't have to send a chunked UDP response, and that's more tricky and cumbersome to set up. So I just limited the random bytes that we send, like a huge payload, to this one. So again, I have a random int function or random IP, same thing as in C. I concatenate a string using a random int. So we have a spoofed source IP address. And then, yeah. So I will, in the main function, we go back to the main function. So yeah, there's the args here, command line args. And I create a wait group and then use this to create a new thread, actually go routine. Then with the target IP from the command line, random port with the 0 on the minimum and max port on the max. And then I use a channel to signal it, and then the bytes, I convert the string to a slice of bytes. And that's where the random payload is, just a bunch of random characters, just rubbish actually. And then I sleep for like half a second to try not to exhaust my resources here and freeze everything. That won't be cool. And yeah, there's actually never the part of the code is unreachable because this is an infinite loop. So I made it like this because sometimes I was testing like with a certain number of threads, so I had to use this. I could call defer here, I guess. Well, so yeah, it would start a go routine with the UDP flood, and then the UDP flood is where the magic happens. A lot of stuff. So it takes an argument, the target IP, the port number, the channel, stop channel to signal that stop the flooding, and the payload, the data. So first things first, you create a socket. It has uses Go library syscall and then create socket. It's pretty much similar to C, like we have a finet, and then sockroll, and then proto UDP. So we're using a proto UDP socket, and then f error check that's not equal to new, blah 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 blah. You know the drill. It defers syscall to call the file descriptor for the socket. And then this is an important part, a very important part that I mentioned when I was talking about C code, that you have to use set sockets options. And then here's basically to tell, hey, kernel, don't worry about the IP headers. We are going to provide it, okay? Otherwise, you will screw with our packet. Don't mess with our packet. That's our business this time, only this time. So this is some flags we have to pass in, like IP, proto IP, and syscall, IP, HDR, and CL, and then one. So yeah, that's pretty much it here, and then we enter infinite for loop. Yeah, well, we'll keep bombing the system with UDP packets. So first things first, we create a UDP header which has 8 bytes. And then basically, yeah, we fill with the length of the payload and the port number. Then we create the IP header which has 20 bytes, and then we use source IP, target IP, and a bunch of other data. Here we combine both headers and data, the IP header, the UDP header, and then we have the packet itself with the payloads. check, you set checksums. Actually, we're not checking for anything. We are passing them a 0 because, yeah. And yeah, here there's some debugging to check like what the IP header is, UDP header, the data payload, UDP length, and stuff like that. We set the destination address, so it's IP version 4 and the port number. And then we copied on some parsing to IP version 4, and then here we can visualize the whole packet, encoding to string and hexadecimal, and then we use a syscall to send to the file descriptor, which is the socket we created earlier, and then the packet, and there's some flag which I don't remember actually. Yeah, it's some flag for the, I don't know. And then the address of the destination address, the address in memory of the destination address. Yeah, that sounds funny. And then we sleep for a second, yeah, just to not spam and exhaust resources. So the most tricky part actually was this filling headers. So like we have called this binary big Indian put sign int 60 bits, and then set up the header with these values and blah 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 blah. So we have here version IHDL, TOS, total length, ID, flags and fragment, TTL and protocol. So all to set up for, yeah, IP header. Is that correct? Yeah. And yeah, here also some parsing. And then fill the UDP header, which is pretty much simpler. Source port, which should be random here also, but I'll leave as this. It doesn't matter for our purposes. Set checksums function and calculate checksum. I think, yeah, this is called here, and then set checksums is called, yeah, the other. And what else we have? Generate rand string. This is simply to generate a random huge payload with a bunch of garbage, gibberish. And that's pretty much it. Yeah. I'm going to compile this. And I have to run it as sudo. I'm going to bomb, let's see, my own computer on local network. That would be 192.168.1.0.1. And I think that's pretty much it. Yeah, so I'm going to open Wireshark and start listening to what I got. So I already got some packets here, but it's not. So I'm gonna press here and let's see what happens. So yeah, I have to type my password again. So yeah, so I typed up my password, and now I'm gonna see what I got. So I passed the local address here, and okay, so I'm starting a bunch of packets, and oh yeah, there we go. So I'm going to stop this before my computer freezes. So yeah, I'm spamming myself with a lot of packages. So let's take one of here. You can see here these all seem to be from like a different IP address, but they're not. They're May, but they're spoofed. Yeah, they're lying. And this is the destination. The protocol is correct. It's UDP, the time, the length, and you can see here the payload all have the same length. It's all the same length. It's all gibberish. It's like just random strings. And let's see what we have here. Frame, I think is, yeah, from the Ethernet. Here the Ethernet, Internet Protocol, blah blah blah, UDP. Let's see the UDP. Source port 12345. That's what we set on the Go program, and then the port is random. Length checksum 0 value ignore, so we didn't provide the checksum, and it ignores. But yeah, it's a valid UDP packet. So let's see what happens with my ping. I'll ping Google, which is 8.8.8.8.8. So I got around 10 milliseconds. Yeah, it seems like I got some little bit of jitter. Yeah, so 0 packet lost, 18 packets transmitted, and I got an average of 11 milliseconds. Okay, fair enough. So let's see what happens when I try to bomb this. And okay, so let's ping. Oh, I thought it was actually going to be a bit worse. Yeah, is it working? Yeah, it definitely is working. I should watch out for yeah, I got plenty of resources. Let's see. Yeah, I think I'm not creating enough go routines, so I'm going to like take one this 250 milliseconds to see if I can break my connection. And not. Let me point this at localhost. Perhaps. And then let's see. Not a big difference. Yeah, of course not, because I didn't compile it. Well, let's see now. Nope. Let's check my resources. Nope. Let me decrease that. So I guess there's a minor jitter. No, it's pretty low. It doesn't seem to be affecting. Perhaps it has to do with that I'm affected connected with Wi-Fi instead of. Yeah, that there's definitely some jitter. Let me try, I don't know, accent. Yeah, probably gonna exhaust my resources this way. Let's increase a little bit here. Yeah, it's definitely, but probably because I'm using a lot of resources. Yeah, it's working fine. Let me try with the local hosts. Yeah, it's not that bad. Okay, I will test something else here. So I didn't got very much any So the thing I'm going to try to measure is the throughput, is how this UDP flood affects the throughput. And let's see, I think it's, okay, server listening on 1501, and then I call the same commands and with the client and specify, I think, 5 2. No, that's not it. Nope. Okay, so for to using this tool to measure throughput and to check also uh, how many packets are, let's say, contained. First, we create a server with iperf3 and then -s. Then we create a server listening in 501 on localhost. And then the next step is to listen to the server. So we create the clients with iperf3 and then the localhost 127.0.0.1. And voila, we get transfer of 12 around, yeah, 13 gigabits per second. Okay. And this is the congestion level of, we got around, increase to 3 bytes. So let's run it again. Around 2 bytes, increasing congestion. Okay. I think we got the report here on the server as well. Yeah, so this is basically the throughput, this value here, which was around, let's see, let's round up to 1.5 gigabytes. So let's test that with the UDP floods and see what happens. So I'm flooding, and now let's see. Yeah, definitely we had a decrease. So let's see, before we had a transfer of 1.5 gigabytes and then it decreased to like half gigabytes. So yeah, our attack congestion, the network by a lot. And before we had a bit rate of, let's say, let's round up to like 15 gigabits per second. And now it decreased to 5 gigabits per second. So yeah, our attack, UDP attack on myself was successful. And let's see the congestion. Yeah, I don't think. Yeah, let me run again just to make sure before. So there's no UDP flood going on now, and the congestion is around 2 megabytes. And with the floods, let's see, with the UDP floods, yeah, it increased to around 3 megabytes, but yeah, with UDP flood, it increased from 2 to 3 megabytes, and yeah, that's not like a big deal, but we could do like better here, I guess, increasing this time. So I don't know, let's put here 200 and then compile and run. I guess here we could leave like to make the packet smaller, and we can send more. Create like a, let's complain here. I will have to create a random slice of bytes. So yeah. So we will send no data here, and then we build, and then let's run this again without um, any flood going on. And here also check my ping. So it's around 10 milliseconds. It's pretty decent. Okay, now I'm gonna run my floods. I should actually build again on localhost. And yeah, that is mayhem. And okay, our transfer was decreased from 1 gigabyte, 1.5 gigabytes to a couple of 500, 200. So we decrease even further because we're sending more packets and despite having less data. And yeah, I think I'm about to crash my computer. Yeah, I should probably stop a bit. Okay. So let me check here. And congestion increased from 1.5 megabytes to 3 megabytes. So let's see what happens to the ping right now. Now that I eliminated the payloads from the UDP packet, you can see like it's setting a lot more packets here. And let's check ping. And yeah, it seems like normal. Perhaps because I'm pinging an external host. Perhaps should try with localhost. So let's ping localhost here. So yeah, let's ping like 20 packets, ICMP packets. And then we check with the UDP flood. And now let's ping. And yeah, no packets lost so far. I guess this is probably has something to do with the fact that I am wireless, because when I had the same test on the Ethernet cable, the results were pretty different. Like it affected a lot ping, and also it had a less impact on the throughput and on the throughput and then congestion rate here, also transfer bit rate, and yeah. So that's pretty interesting results. So hope you guys liked this video. Don't forget to like, subscribe, and comment. And share this video with others. And yeah, I probably will be leaving this uh, source code in the comments of the video. And yeah, see you next time. Bye.